We can also look at creating a frequency distribution for quantitative data. In this case, students in an English class were asked, on average, how many books do you read each year? And then we have those responses provided below. So we would look at counting the number of times each response was given. 0 in this case was given 3 times. 1 book per year was the response 4 times. No one responded, 2 books per year. So we drop in a 0 there. And then we get 3, 3, and 2. Again, if we imagine this as a much longer list, if more people were surveyed, even if the numbers are only between 0 and 5, looking through a longer list would start to become a little meaningless. So we group the information together in a frequency distribution, which just gives us a summary or a better idea of what types of responses are coming in. When we're talking about quantitative data, we can also look at creating a binned frequency distribution. So that's our difference in this last example. Here, a group of college students were asked how many hours they spent playing video games last semester, with the responses provided below. The advantage of a binned frequency distribution is, in this case, that the numbers can be so varied. Just looking at the number of times, say, 77 occurs, wouldn't be very useful. So instead what we do is group the values. And the way we group them just depends on the situation, the scenario. In this case, we have bin widths of 50. So our first bin is going to be any responses between 0 and 49. So that represents a bin of 50 values. But we'll approach this in the same way. We'll go number by number and just put a tally mark or somehow count up the number of times we get something in each bin. So our value of 18 would fall into this first bin. 138 would fall into the third bin. 52 would fall into the second bin. 77 is also in that second bin. Then we would get 162 and 176 both occurring in the same bin. 57 would be in the third bin, along with 94. 201 would be in that second to last bin. 270 would be in the last bin. 19 in the first bin. 289 in the last bin. 98 would occur in the second bin. 202 in the second to last bin, and 14 occurs in that first bin. Then we would just tally up how many times we have a number occurring in each of those bins. So 3, 5, 1, 2, 2, and 2. And again, we could add those results together just to verify that this comes to a total of 15, since we had 15 different responses in our survey. And what we're doing here, again, is just putting things in this binned frequency distribution, because counting each individual response wouldn't make a lot of sense, since the responses can be so varied. We group them together, and again, that grouping, the bin width, really is just contingent on the scenario that we're considering. There might be some common sense number that we want to use. For instance, if we were looking at grade distributions, we might use 10, because 90 to 100 is an A, 80 to 89 is a B, or there would be something else to guide us, or we just have to make a decision on what that bin width should be for the given problem.